Good day, everyone. You're welcome to Bontutor channel. We are still on plane shapes, and today we'll be talking about congruent and similar triangles. And these are two types of relationships we have among triangles, which will help us understand much more about triangles. If we're talking about congruence of a triangle, let's say we have a rectangle with a diagonal being drawn across the rectangle. You will notice that this rectangle with the diagonal drawn across it gives you two triangles rather, two different triangles. And you will notice that the line here is equal to the line here, and the line here is equal to the line here. If the line here is equal to the line here, and the line here is equal to the line here, that means the triangle that you have up here is exactly equal to the triangle you have down here, because the diagonal is the line that forms an hypotenuse for the two triangles. Because the two triangles are the same in all aspects, checking the lines which are the sides and also checking their angles. You have angle 90 here, you have angle 90 here. You have 45 here, 45 here, you also have 45 here, 45 here. Which means their angles are equal, and also their sides are also equal. Therefore, we can say the two triangles that we have here, let's say we have here to be A, B, C, D. That means ABD, the triangle ABD is congruent of triangle BCD. And there are conditions that must be met before we can say two triangles are congruent of each other. And the first condition is that in those two triangles, they must have two sides to be equal. And the angle between the two sides that are equal must also be equal. Which means you can represent it as the first side equals to the other side. Also, the angle between them is equals to the other angle, and also another side is equal to the other side. In case of that, let's use this triangle as an example. This side and this side are equal to this side and this side, which means we have two sides equal already. And the angle between the two sides that are equal is also equal for the two triangles. You have 90-degree here, you have 90-degree here. These two sides are also equal to these two sides. That's the condition we are talking about. Another condition also is that two angles must be equal with also one side. Two angles must be equal with also one side. This angle and this angle are equal to this angle and this angle. Also, this side is equal to this side. Therefore, it's a condition that has been met, and we can say these two triangles are also congruent of each other. Another condition that must be met is that at least three sides, if three sides of the triangles are equal, we can say they are congruent of each other. That is, the way this side is equals to this side, and also this side makes these two triangles to be congruent of each other. That is, side AB is equal to side DC, side AD is equal to side BC, and also this DB is equal for the two triangles. Therefore, we can say these two triangles are congruent of each other. And in case of a right angle triangle, once the hypotenuse of the triangle and also one of the other two sides that remains are equal to each other, we can say a right angle triangle, and the two right angle triangles are congruent of each other. Once the hypotenuse and the opposite is the same for the two triangles, or the hypotenuse and the adjacent are the same for the two triangles, we can say the two right angle triangles are congruent of each other. On the In short, when we're saying a triangle is congruent of one another, we are just trying to say they are equal in all aspects, in angles and also sides. So once the angles and the sides of the two triangles are equal to each other, we can say they are congruent of each other. But in the case of a similar triangle, the case of a similar triangles are different. In congruent triangle, the sides must be equal and also the angles must be equal. That is, in short, the two triangle must be equal in all aspects. But when it comes to similar triangle, the only condition that must be met is that all the three angles in those triangles must be equal to each other. The sides can be different, they can be longer or shorter than each other, but as long as the angles you have there are equal to each other, then you can say the two triangles are similar. That is, let's say this is triangle ABC and this is triangle PQR. You will notice that your AC is not equal to your PR. Yes, your AC, sorry, your AC is not equal to your PR, and also your BC is not equal to your QR. Is not equal to your QR, whereby your AB is also not equal to your PQ. But one thing you will notice is that your angle A is equal to your angle P, your angle B is equal to your angle Q, and your angle C is equal to your angle R. Therefore, since this condition has been met, whereby all the three angles in those triangles are equal to each other, we can say the two triangles are similar to each other. And because of their similarity, that leads us to what we call a corresponding side. Truly, this side is not equal to this side, but because the triangle are similar to each other, there will be a certain ratio that will relate this side with this side and also this side with this side, that will relate all the two sides together. What I'm trying to let you understand is that truly the sides are not equal, but it is just a magnification of the smaller triangle. This big triangle is like a magnification of this small triangle. Therefore, there will be a scale factor that will relate this triangle with this triangle. And for you to get the scale factor, you have to consider what we call the corresponding ratio of the sides. The corresponding sides is telling you that truly AC is not equals to PR, but AC is corresponding to PR. The same thing applicable to your AB is corresponding to your PQ, whereby your BC is also corresponding to your QR. Since these sides are corresponding to each other, for you to get the scale factor, it means if you use your AC to divide your PR, whatever value that you have must be equal to if you divide your QR with your BC. That is your AC, sorry, that is your PR over your AC must be equal to your QR over your BC, which also must be equal to your PQ over AB. And any value you get here is what we call a scale factor, which is the factor of magnification of these two triangles. And if you are able to get the same scale factor for this triangle, which means these two sides are corresponding to each other, you can just say the two triangles are similar to each other. Let me give us some examples on the congruent triangles and also on similar triangles for us to be able to identify the difference. Now let's check these examples. These are two different shapes that consist of triangles. So let's check this first one and see if it's a congruent triangle or a similar triangle. We say when we're talking about a congruent triangle, we're talking about triangles that are equal in all aspects. That is, all the angles and all the sides are equal. And when we're talking about a similar triangle, it only have corresponding sides, but all the angles in them are equal. Now let's check this. These are two parallel lines. This line and two lines are two parallel lines. That is, line X and line Y are two parallel lines. And if you check this side here, it serves like a transversal for a parallel line, whereby whatever angle that you have here will be equal to the angle that you have here, and that is called a corresponding angle. The same thing applicable to this side also. Whatever angle you have here is also equal to the angle you have here. It's also called the corresponding angle, because this line here, this side here and this side here will serve like transversal for these two parallel lines, whereby the two triangles share the angle at the top here. We can then say all the angles we have in this triangle are equal. That is, the angles we have in this small triangle is equal to the angle we have in this whole big triangle. Since the angles are equal, and we can see that the sides of the triangles are not equal, therefore we can say these two triangles are similar triangles, whereby this small triangle is similar to this big triangle because they share the same angle, but they have different sides. Since they are similar triangle, for us to find the ratio of our x to y, they said, let's say find ratio x to y. If you are looking for the ratio x to y, since you know that your x will be corresponding to your y based on the rules of a similar triangle, therefore also the sides of those triangles, also the other sides of this triangle will be corresponding with each other. So x ratio y is same thing as saying x over y to be equals to, let's look for the side of this small triangle which has the size x here, that is also corresponding to the given size of the whole big triangle, and that will be this 3, which is this side, to be over the whole size which is corresponding to it, which is 5, because 3 plus 2 gives us 5. Therefore we can say our x ratio y is equals to 3 ratio 5. Let's come to this other one also. We are also looking for our ratio x. Find x ratio y. So if you're looking for your x ratio y also, you can see that we have two parallel lines also. So we firstly have to check if it is congruent or it is also similar. And with that, let's check it also. If you extend this parallel line up here and you extend this parallel line here, you extend this parallel line and you extend it here also, you will see that this line also is also a transversal for the parallel line. And if it is a transversal, the angle you have here will be equal to the angle you have out here. The angle you have here will be equal to the angle you have out here. And if the angle you have here is equal to the angle you have out here, which is the corresponding angle, the angle out here will be equal to the angle inside here, and that is called vertically opposite angles. We said vertically opposite angles are equal. Therefore, the angle you have here is equal to the angle you have out here, which is also equal to the angle you have inside here. And the same thing also will be applicable to this side also. This is also another transversal for the two parallel lines, and whatever angle you have here will be equal to the angle you have out here, which will be equal to the angle you have in here, which is also transversal. Which is also a vertically opposite angle. This angle is corresponding to this angle, but this angle is vertically opposite to this angle. So the last angles for the two triangles we have here also, this angle here will be equal to this angle here, vertically opposite angle. Whatever angle you have there will be equal to the angle you have there, which is vertically opposite angle. We can then see that all the angles in those triangles are equal, but note one thing: the sides are not equal. The triangle up here is bigger compared to the triangle down here. Therefore, we can say the triangle are similar. And since they are similar, they will also have corresponding ratio. That is, their sides will be corresponding to each other. And we are looking for x ratio y, which is the same thing as x over y. Look for the sides that is corresponding, that is corresponding from the small triangle to the big triangle. We will notice that this side here is corresponding with this side up here. That is, your 12 is corresponding with your 20. Your side 12 is corresponding with your side 20. Now we can say 4 here 3 and 4 here 5. So your x over y also is 3 over 5. That is, your x ratio y is equals to 3 ratio 5. The two have same ratio. This is how you solve a similar this is how you solve a similar triangle. You just have to check for the corresponding side. This side here is corresponding with this side. How? You can notice that the angle suspended by this side is equal to the angle suspended by this side. Therefore, this side is corresponding with this side is corresponding with this side, and this side is corresponding with this side. So whenever you see any similar triangles, just check the angle suspended by those sides, and you'll be able to identify the corresponding sides in those triangles. If you have any question on congruent or similar triangle, please don't hesitate to drop it in the comment section below, and I will be answering every comment as soon as possible. Thank you for watching this video. Have a wonderful day. Don't forget to subscribe and like. Thank you very much.